So good morning, everyone, and welcome to the Parent Resource Center's presentation this morning. Math Matters, Supporting Your Grade K-2 Children in Mathematics. We are very excited to have you here this morning. But first, I would like to introduce Dr. Spencer Jamison. He is an educator leader in Fairfax County Public Schools in Fairfax, Virginia, has served in various roles from a classroom teacher, a K-7 math teacher, and a mathematics coach. Spencer currently is serving as a K-6 mathematics educational specialist. His passion in math involves the coaching of teachers, cohesiveness of curriculum, and equity for all. As an advocate of lifelong learning, he has challenged himself by earning a master's in curriculum and instruction, an endorsement in administration, K-12, and as a K-8 mathematics specialist, and has a doctorate in mathematics education leadership from George Mason University. He has presented at numerous conferences and loves to talk about mathematics with anyone that will listen. He currently serves as the Publication Community Chair for the National Council of Teachers of Mathematics and has served on the Virginia Council of Teachers of Mathematics board as the Mathematics Specialist Representative and was the past president for Virginia Council of Mathematics Supervisors. We are very excited to have Spencer with us this morning. Welcome, Spencer, and thank you so much for joining us today.
Well, thank you very much. I am super excited. Matter of fact, anytime I get to talk about math with people that want to hear about math, this is making my entire week. And it's nice that it happens on a Friday so I can continue to have that joy throughout the weekend. So as you stated earlier, one of the things that we're going to be doing is we're going to be interacting quite a lot today. And so I'm going to ask you to be typing things into the chat as we kind of go through the day. So let's get started. So take a look at these 4 pictures. And I want you to think about, what was your math experience in school like? And then in the chat, I want you to put 1, 2, 3, or 4, whatever experience you had in school. What was that like? Was it more like the picture 1, picture 2? Fantastic. So, as I look at each picture, I'm sure you have a different story that goes with it. But that first picture of the storm, sometimes math was hard for people. And guess what? It's okay. That's not your fault. And then maybe your experience was more like number 2. And I saw some people put in 2, that it was the smooth water that you really got to understand math, and maybe it was just that smooth sailing as you kind of think about it. I also saw people put in picture for number 3, the roller coaster, where you were just continuously going up, 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 working towards the very top as you kind of move forward. And then we had some people do number 4, where number 4 looks to me like you're just trying to solve problems and figure things out. So I'm going to be honest, my math experience at the beginning as elementary was definitely a 2. I was smooth sailing in elementary school, not a problem. And as I got older, when I went to middle school and then high school, I started to get some rockiness. So I probably would switch to 1 as we kind of went through. And then as I graduated from high school and went on to college, definitely it was an uphill climb because I needed to do some relearning and rethinking about what mathematics really meant to me. And then I would probably say right now, math for me is a 4, where I just want to love the problem solving and think about it as we kind of move on. So thank you for sharing, by the way. So let me share a little bit about myself. So as you can see, the picture all the way to the left is a picture of me. I am the mathematics educational specialist for Fairfax County Public Schools, and I love this job. It is a great job. I get to talk about math and focus on math all day, every day. So it is definitely a dream job for me as I move forward. In the middle, you see a picture of some of what I do, of who I am and kind of why I do it. So you'll see my family there. That's my wife and my two sons. My oldest son, we're actually in this picture, we're taking him off to college. He goes to Virginia Commonwealth University. And then my younger son, who is in 4th grade. So like you, I have children that are in school learning this math as we kind of move forward. And then the last picture you might not be as familiar with. It is actually Pascal's triangle. And the reason why I kind of decided to represent my love of math with Pascal's triangle, because I think it really fits the 3 pieces that I really tried to strive for when I think about math. And it's focuses on patterns, because there's a bunch of different patterns in there. And it focuses on relationships, because relationships are important. Relationships with numbers, as in relationships with family and those things. And also the connections. How do we make those connections together as we kind of move forward? So all of those ideas of math really helps us thinking about connections. So let's talk about what we're going to be doing today. So today we're really focusing on 3 big ideas. Really 3 ideas that if you do these things, you're really going to help your child understand mathematics at a deep level. And the first one is focus on understanding, right? The second would be asking questions. This one's really important also. And the third one is math takes time, right? Think about my journey that I was talking about and how it took me time to get to where I needed to be. And it's okay to take that time, because we all learn at different intervals as we kind of move forward. So let's talk a little bit more about focusing on understanding. So I love this question. How is math different? I have friends all the time come up to me and say, math is different. It's this new math. Well, I'm here to tell you, math isn't different. 2 + 1 still equals 3. So you can take a nice breath right there and say, I knew that, I'm good with that, I'm going to be able to help my child, and we know you'll be able to do that. Let's talk about this problem here. This is actually a classic 2nd grade problem. 12 take away 9, right? 12 take away 9. I know some of you are like, this is what the answer is. But if you ever sit in a 2nd grade class, this is what you see. Kids do this, right? They just put these, cross out that 1, cross out the 2, make it a 12. And guess what? This problem is still 12 take away 9. It didn't change at all. So when children do this, they are actually focusing on the procedure, right? This is what I need to do to solve the problem, versus focusing on the understanding. And that is really something that we are trying to get kids to do. And that's really how math is different. Probably like many of you on this call, we learned math because someone said, this is what you have to do, and you had to memorize it, right? And I'm not saying there's not pieces that we don't need to memorize. What I'm saying is we are now shifting the idea of just memorize, just memorize, just memorize, to this idea of understanding, and really thinking about what is that understanding that we need to do, and how do we go about it. So I'm going to click to this next slide, and this one really focuses on kindergarten understanding. So I'll give you a second to kind of read this. And there's a few things I want to kind of point out. These are the big 3 understandings for kindergarten. When your child leaves kindergarten, these are the 3 things we want them to do, right? We want them to be able to really understand the number and to be able to count and compare sets of objects, right? So that means as a parent, one thing I can do, especially if I have a kindergartner, is I'm going to be counting everything, counting stairs, counting how long it takes to do things, counting forwards, counting backwards. And I'm also going to be comparing. I might say, how does this many steps compare to those many steps? And have kids think about it. So you want to start thinking about those questions as we kind of move forward. Another part of the understanding for kindergarten is really this idea of patterns. Patterns everywhere. And not only do we want kids to be able to identify the patterns, which is the first step, is we want them to be able to describe them and extend them and create and transfer patterns, right? And it's that idea of patterns being so important in math and so important to the numbers and geometric shapes that they do, that they should be able to talk about them. Along with patterns is this idea of we're going to take these patterns and we're going to talk about the different attributes of them, right? Whether it's numbers or geometric shapes, and then we're going to have them sort and classify those attributes. So those are the three big understandings for kindergarten. So let's talk about first grade. First grade is very similar to kindergarten, which is good because that's one of the great things about math that I love, is that it builds upon itself, right? So what we hope for kids in grade 1 when they leave is that they have these three understandings. I'll give you a second to kind of look through them. So maybe the first thing you notice is that the first bullet is really similar to the one in kindergarten. Now, the one in kindergarten, we're really talking about counting and comparing objects and sets, probably up to 20. But now the jump is up to 110. And it's the same thing. We need to be counting. We need to be comparing. We need to be skip counting, counting forwards, counting backwards, counting by 5s, counting by 10s, counting by 2s, counting by 2s starting with 3, like 3, 5, 7. You know, a lot of times we count by 2 starting with 2, 2, 4, 6. So really having kids think about it, or counting by 10, starting with a different number like 8, 18, 28, to have kids really see the patterns in the idea of counting and comparing. The second one is a little bit different than kindergarten because it really focuses on whole number relationships. A little bit later on, we're going to talk about questioning. And this is where it's really going to support this idea of whole number relationships. And it's this idea of we're going to group things into tens and to ones. And once kids understand that relationship between tens and ones, that is the building block of all math that they're going to be doing moving forward. So no pressure in grade 1 if you have a child that's in grade 1, right? Because we all learn at our own pace, but that's where we're really focusing on. And then the last bullet, which probably seems somewhat familiar to probably a lot of us, is that it's the focus on basic facts, but it's not the memorization of basic facts. It's really focusing on that addition and subtraction are related. And because of that relation, I can think about math in a fluent way. I can go back and forth. And that helps support my facts as we kind of move forward. So let's talk about grade 2. Take a second to look at grade 2. And as you can tell, probably the big three things for grade 2 are very similar to grade 1 as they kind of continue to build, right? It's this base 10 numeration system and the place value concept, right? And these are numbers as we go on. So after 110, what happens? You know, after 100, after 200, after the hundreds, what happens? So we want kids to really start expanding their numbers in this part and really think about the place value. What does that mean if I have 2 10s? What does that mean? What does that look like? The other two bullets really focus focus on the idea of fluency. So I want to kind of talk a little bit about fluency. Fluency does not mean rapid recall. Fluency means that you have a strategy that is efficient, that you understand, and that you're able to support your thinking as you move forward. Do I want kids to be able to say 1 + = 3? Absolutely, just like that. But I do want kids to think about, as they're moving forward with their addition and subtraction facts, to really think about, what are some good strategies to help me if I don't know that problem? Like if I didn't know that 5 + 6 was 11, I might say 5 + 5 is 10, and I know 6 is one more, so I'm just going to say add one more to 10, that gives me 11. So having strategies that are ready. Don't worry, I promise you, they will be able to do rapid recall of facts as they move on throughout their grade. All right, I've done enough talking. Now it's time for me to put you guys to work. We're going to do some number sense activities. These are short activities, and I'll share with you where I got these resources at. And they're pretty much out anywhere on Google, and we'll talk about them. But I'd like you to kind of participate with this as we kind of move forward. So this one is called Splat. So I'm going to ask you in the chat to type, how many blue dots do you see? All right, so I see a lot of people putting in 17. So I'm hoping that is correct. Yes, 17. There are 17 blue dots. Now, one of the things I would ask is, how do you see those dots? How did you count up those dots? Now, this is going to be a little bit hard, but what I like, a few of you, groups of 3, yeah, that's exactly what I was going to ask. How did you count them up? You grouped them by 3s and 4s. You saw some, you kind of put patterns around them. Did other people find a different way? Group by a line. I definitely see some lines in there that helps us think about that. And this is a big thing with brain research. Do you know, if you put, your brain can only hold about 5 to 7 objects as single objects. Once you go past 5 or 7, and everybody's brain's a little bit different, your brain automatically starts grouping things. And it's that grouping that's important, that you have that discussion with your children. That helps develop their understanding of what 17 is. So I'm going to go to the next slide, and you're going to notice that something happens. Watch. Uh-oh. Splat happens. Right? So my question here is, how many blue dots are under my splat? And if you don't mind, you can type it in the chat. So the bigger question is, because I see a lot of people put 11. How do you know it's 11? What did you do to figure out that it was 11? So people said we know the total, so we subtracted the visible dots, right? So that I 17 minus 6. Yeah, so that number up there, that's exactly why that's there. You're exactly right, up in the corner. So one of the things I want to point out is, we're adults. So our thinking about math is already kind of been formulated, and we have like a concrete way of looking at it. But if I did this in a kindergarten class, or in a first grade class, or in a second grade class, I would have some kids do this. Well, I see 6, and then I went 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? And they use their fingers and a toe, maybe, to help them figure it out. So kids think about it differently, and that's one of the questions I want you to, so how did you do it? And what came up with it? So thinking about the bigger understandings that we talked about in math, whether your child's in kindergarten, first grade, or second grade, how might this support your child's understanding based on their grade level? What do you think? Feel free to type it in the chat. All right, I see that no one is typing in the chat. You know what that means? I need to build a better community here. So we're going to come back to these questions. I'll kind of answer this question a little bit. It's a answer. It's not the answer. All right. So I want you to go out there and take risks. So, and I appreciate everyone that's already done that. But I'm going to keep pushing you to really think about math as we move forward. So ways that this might support understanding it. Oh, someone wants me to restate the question. So the question is when we looked at your child's grade level understanding for math, how did that activity SPLAT help support those grade level understandings? All right, so I'm thinking in kindergarten, yeah, the abstract thinking, you're absolutely right. I'm thinking in kindergarten, it supports kids' understanding about counting. Because if I did this in kindergarten, the majority of my kindergartners wouldn't do the subtraction problem because we really haven't done subtraction yet. Even though they understand subtraction and they've been really doing informal subtraction the majority of their life, they would probably be doing a lot of counting. So I'd be asking, well, how are you counting? How are you keeping track of your counting? What are you doing? Some people might say, well, I started with this pattern. I saw 6, and then I counted on. And some people would have said, I'm just counting from 1 and figuring it out. So in first grade, some of the kids might have said, well, I'm thinking about this idea of adding and subtraction. So a lot of people kind of put this idea down. And this really goes with second grade also, is this idea that I had 17 and I see 6. So that means whatever the difference is, that's going to be the solution for that problem. So this activity works in a deep way to really kind of focus on kids' understanding. And one thing I like about SPLATs is they're fun. And as I always say, if math isn't fun, we're doing it wrong. And that's one thing I really try to preach, is that math should be fun. And that's what I really love about SPLAT. So let's talk a little bit more about SPLAT. And the SPLAT that we did was from Steve Wyborny, and he has a whole bunch of different SPLATs. He actually has them from all the way from kindergarten all the way through Algebra 2. They definitely get more complex as you kind of go on. But you don't need to use a computer to do. You can use some pennies or some coins and a cup. I used to play this game when I taught kindergarten with my kindergartners, and we called them bears in a cave. I had some little toy bears. I stuck them in a cup, and I said, how many are in the cup? And they would have to tell me how they knew. It helps students really understand what those numbers are, how to break them apart, and how to put them back together again. Because that idea of 17, we can think of 17 many ways, and we want kids to think about 17 in many ways. We want kids to think about it as 10 and 7, right? We want them to think about it as 11 and 6. And you'll have some kids who will think about 17 as 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. A lot of different ones that make up 17. And we want them to think about those different ways of thinking of 17 because that gives them flexibility as they move forward. All right, so let's do another activity. And this one I like a lot. It's called Which One Doesn't Belong? So I'm going to ask you to look at those 5 cubes. And I want you to type in the chat which one doesn't belong and why. All right, so someone said the one that only has the 1 dot or the 1 pip, right? Because all the other ones have 5, they're all 5. Someone said blue doesn't belong because it's a different color. Yeah, someone also said each one doesn't belong for different reasons. Yeah, you talk about size and why it might not belong. Or the top left one could be that the idea that 5 is written as a numeral. The others are more of a picture model, right? Yeah, there's many different reasons for this as we kind of go on. So we're going to ramp this one up and we're going to change it a little bit. And this time I want you to tell me which one doesn't belong and why. So I see people putting 16 because it's the even one. 9 because it's the only one that it's in the ones place. The other are 2-digit numbers. What I like about which one doesn't belong, this is a good one for the whole family. That it really kind of spurs it. And you'll be amazed with what your families come up with. Oh, look at this one right here. If you add the sum of the digits, they equal 7. So 9 doesn't belong, right? So 1 and 6 would give you 7, 2 and 5 would give you 7, and 4 and 3 would give you 7. But so 9 wouldn't belong in that case. How about 43? Why doesn't 43 belong? Oh, someone put 43. I'm kind of curious why 43 doesn't belong. It's not a square number. Okay, I'm going to let you know right now. Kids in K-2 don't need to know that, but look how cool that is. And that's what I really like about that. And you would be surprised that you will find some first graders and second graders know something about square numbers. 9 is the only one divisible by 3. Yeah. What I really like about this really differentiates for every person that kind of looks at it. And that's the power behind which one doesn't belong. So guess what? I'm going to ask that same question that I asked about splat. How might the activity, which one doesn't belong, support your child's understanding? Feel free to type it in the chat. Yeah, it's definitely that idea of breaking down numbers. And that's something that I know when I was in school that we didn't actually do a lot of breaking apart numbers and putting them back together. The fancy math word for that is called decomposing numbers and recomposing numbers. You don't have to use that language, but I just want to let you know there is actually a mathy word for it. Yeah, the idea of being able to see patterns, right? And think about the patterns. Because what happens as we get older and we go to algebra, we have to think about numbers differently. And you probably remember it, when you took algebra that we had to do these things with letters, and you're like, what am I doing with this letter? I'm not even exactly sure what that means. So it helps us think about it in a more abstract way. So we're kind of training that brain to really be thinking about the relationships with numbers, right? And once again, just like Splat, it's fun. We're having a conversation. I'm not solving 52 problems on a piece of paper. We're talking about math. And that is something that is one of my personal goals I'm trying to put forward, is to really try to talk about math as much as possible with your kids, right? So let's talk about this idea of understanding a little bit more. And I want you, I don't think these links are going to work. That's okay. I've learned something. Next time I'm going to put in the link. So what I'll do is I'm going to, at the end when we have the questions, I will actually, in the chat, I will put in the links for these to make sure that we have them, or I'll ask someone if they could do that for me. That'd be awesome. But I do want to talk about some resources that really help support you as you help support your child with their understanding. The very first one is the Virginia Department of Education. They have on their website, they have something dedicated just for mathematics, and it really helps you focus on the content understanding, the pieces of the content that really that kids really need to know as they move on. So this site actually is going to be a site that you're going to want to bookmark and keep for a long time, especially when it comes to mathematics, because it goes from K all the way up through calculus. It talks about all the different ones. So it's a great site for you to kind of poke through and enjoy. Thank you, Valerie. And then the second one underneath of it is a link directly to like the sense making, which is some of the work that we're doing. The bottom two were websites that are on Google. So Steve Y. Barney, he has a wonderful site that, what I love about it, one, it's free. And two, it really, everything on his site really promotes this idea of student understanding, students thinking about mathematics, children really grappling with that idea of what is math and what does it mean. And then the which one doesn't belong. You definitely can, as you can see in the chat, they're there, but you can Google those too. Those definitely will help as you kind of move along. So when we're thinking about helping our kids, one of the things that really has changed when we think about math is this idea of answers and questions. And I'm going to ask you to really focus on the question piece. It's about the questions that you ask, because the questions that you ask help your children with the journey that they're going on. So it's really focusing on the questions that support the understanding, right? So with that being said, let's think about questions. And let's look at this picture. What questions do you have when you see this picture? Feel free to type your questions in the chat. How many donuts? Which one is delicious? Absolute. What flavors? How many colors? How many brown and pink donuts are there? Are there any gluten-free donuts? These are all great questions. What flavors? What patterns do you see? All right, I'm going to go to the next question I have for you when it comes to this picture. And some of you already have some of these, but what math questions does this picture bring to life? What I make that New Year's resolution. That's true. How many? What shape? How many donuts do you see? How many donut halves are there? So I want to kind of step out and talk about the two pictures. They were the exact same pictures, by the way. In the first one, I just asked what questions kind of come up with that. And I would use that with your own children. And a lot of times what we do with kids, we ask them, what do you notice? Right? What do you notice? And they notice all these things, same things that you guys noticed, that some had sprinkles, some looked like they were chocolate, some looked like they were strawberries, some see all the donuts, some you couldn't, right? So they're just generating ideas. It allows everyone access to this math idea. And then after that, I asked a question about what math questions does the picture bring to life? And that's really focusing on, so what are you wondering about when it comes to this? And since we're talking about math, we have to think about, how many are there, or we might think about how many colors. So it's that idea of why it's great to think about, the different flavors and the sprinkles. What is the math? Because math is everywhere we go. And the more that we can help our kids think about it and ask questions about it, that really supports us. So let's think about the focusing on different questions. Now, there are tons and tons of different questions that you can do, right? Depending on the problem. But the first two questions on this slide, I think, are some of the most powerful. It's what do you notice and what do you wonder? And as you look through the other questions, one of the things I want to show, I hope you see, is that nowhere on this slide does it say, what is the answer, right? Because the answer really doesn't matter. If we're trying to build understanding through questioning, it's about the journey your child's on. So we want to ask questions that open up that idea. And I'm going to tell you something that's going to be really hard for a lot of us, because we're all parents, myself included, as you saw in that earlier slide, that when it comes to math, I'm going to ask you not to give the answers to your kids. Have them prove it to you, right? By the way, that's very hard because as parents, we like to help. And sometimes helping is just say, this is what the answer is. I've been guilty of it. I don't have a halo, but it's something that I try to practice with my own children, is that I always ask them questions. I remember one time when I was teaching second grade, and this is when I decided that I was going to ask questions. I gave out a word problem, and my kids said, hey, I don't know what to do. And at that moment, I had to make a decision. I had to say, I'm going to tell them what to do, or I'm just going to ask them a question. So I decided I was going to ask a question. So I said, what do you think you need to do? And they said, I don't know, as most kids always do. I said, well, what do you know? What do you notice? What do you know? And they're like, well, I know there's some numbers here. Great. What do you think we need to do with that? And then they started thinking about it, and they were able to work through the problem. And that's the power behind questioning, right? Because a lot of times when kids ask questions, they're not really asking for the answer. Sometimes they're asking for the answer, depends on the question. I also have a 19-year-old. Sometimes he just wants answers. I understand too. But the children are really trying to help themselves think, and that's what your job is. You're trying to help them think through as we move along. I love the last question on this, focusing on question, is where is the math? And I think this is a question that I try to get my teachers in Fairfax County to ask a lot. So I'm going to ask you guys to ask your children, so where is the math? Because math is in everything that we do. And if they can start thinking about that, that really helps them make those connections and develop that understanding. So let's do some more. This sense-making routine is called alike or different. So in the chat, you'll see two, well, on the slide, you'll see two pictures. And I want you to tell me, how are they alike or how are they different? Yeah, wrote that both are squares, size, different color. There are two squares, different orientation. Yeah, so that orientation throws off kids, by the way, a lot of times. They don't think the yellow one is a square sometimes. They're like, oh, that's a diamond. And by the way, it's not a diamond. There are only two diamonds. Diamonds are jewelry or a baseball diamond. It's called a rhombus, and all squares are rhombi. Just that's a side note for you. But yeah, if you look at these, kids, anyone can kind of tell you that there are some differences, and they are also alike in how they are alike. Now, kids would probably say, oh, they might have sides, right? They might not say the word square. Hopefully they are, but if not, that's okay. They might talk about the corners. Yeah, the different colors. You're absolutely right. Right? So I want you to now think about, what questions did you hear me ask when I showed that last problem of the squares? What questions did you hear me ask? What's like, what's different? How are they alike? How are they different? What is different? What is alike? Yeah. And it's just a simple question, right? What do you notice? Yeah. By asking those simple questions, it allows kids to access the problem. And that's really what we're trying to do, is have kids access the problem as we move forward. So your questions are powerful. You don't want to ask too many questions. You want to just ask a couple questions as you move forward to have kids think about it. So I'm going to show you another one. So this question says, how do you know that 3 plus 4 is the same as 2 plus 5? So I want to know, how do you know? So I hear people saying that the sum is 7 for 3 plus 4, and the sum is also 2 plus 5. But how does that make them the same? Yeah, 3 is 1 more than 2, and 4 is 1 less than 5. So you're kind of moving some numbers around. All right, do you know the questions I'm asking? And someone wrote earlier that these are very open-ended. That's exactly right. With an addition problem, you're exactly right. The result is the same amount. I really like these problems because it allows us to ask good questions. And also, typically, the way that we ask these problems would be this. 3 plus 4 is what? And people would just say 7. So I'm looking for the answer versus the action that I want to be taking place, right? So it's very open. I try to make these very open. Another thing that you can do is one of my favorite activities is this called a slow reveal. So what do you notice? Looks like a growing pattern, someone said. Yeah, colors are getting darker, it looks like, from left to right. Looks like it's smaller to larger as we move left to right. It's a graph with increasing bars. All right, so here's a follow-up question. What are you wondering about when you see this graph? It is a graph, you're exactly right. What are you wondering about? Yeah, what is the information that's tied to it, right? What does each bar represent? What are they counting, and what does this really mean? Are they all increasing at the same level? What does it represent, right? Let me give you a little bit more information. So if you notice on the left-hand side, something happened. Now what are you wondering? What it represents? What do the numbers stand for? What unit of measure? Let me give you a little more information. Oh, that's a lot more information. Now, something that you notice or something that you are wondering. Or just something that you know. Yeah, the idea that 80 is the alligator and has the most teeth out of that group right there, right? Do you find anything interesting? Compares different animals by numbers of teeth? Someone said they were surprised that the lion and human have almost the same amount of teeth. Mice have a lot of teeth. You're exactly right. Have a lot of teeth. Yeah, an alligator has more teeth than a shark. Look at that. So this graph is missing a title. What do you think a good title for this graph would be? Comparison of total teeth across species. Animal teeth comparison. Who has the most teeth? Those are all good titles. We could use any one of those titles. I tell you where I got this graph, they didn't have a title. So I'm gonna have to take one of these titles and give it to the people that I borrowed this title from, University of Florida. I need to give them a title for their graph because all graphs need a title. So I'm going to ask you a question. What questions did you hear me ask? And how did it push your thinking on what I wanted you to focus on? Yeah, can I get a title for the graph? What do you think? What are you thinking? Yeah. What do you wonder about the facts in the graph? So I'm going to tell you right now, Fairfax County Public Schools, our children are the greatest at making graphs. They are the greatest. They can make a bar graph better than any other kid, I think, in the whole United States. But where we fall down at is the analyzing of the graph, right? And that's something that we can do as parents, whether we're doing a slow reveal graph like this. When we talk about data and we talk about graphs, we need to be focusing on the analyzing. And that's what I really love about a slow reveal graph. I slowly showed you information, and that caused you to focus on different aspects of it. And so my questioning around it really had you focusing on the important information of the graph versus just me showing you the last graph and saying, what does the graph say? So it's making you focus on different parts of the graph. And that's one thing I really like about a slow reveal graph. So let's talk about some resources that might help you. So a great site is this Marilyn Burns blog. And Marilyn Burns is a math educator that has been around for a long time. She is, I would probably say, the queen of mathematics education. And everything she's done with children. So it's all based in research. And I think this blog really helps you with this idea of questioning. She has this whole section on this blog that talks about questioning and really developing the idea of how to ask those good questions. Yes, I gave you some questions at the beginning, but eventually you might want to try some different questions. So that's a great thing. One of the things I want to point out is that where I got these images, I actually went on Google and I typed in graphs, and then I clicked on images, and then I chose an image and I just put it on, right? You can print it out, you can put it on a slide if you want to. You don't have to do that. It's just a good place to have conversations with your kids as you're looking at graphs. Now, I do want to forewarn you, if you're going the Google route, is that you preview the graphs first, right? To make sure that they're appropriate, that they're graphing something that's appropriate for kids to look at. And then I want to draw your attention to that note at the bottom. And I truly believe this, that if you are giving a problem to kids and you're struggling with this idea of coming up with good questions, then maybe it's not really a good problem children should be doing anyhow, because it might not be that important. So questioning is a big part of supporting kids as they move forward with their understanding. And that kind of brings us up to this next slide, which is this idea of math takes time. Now, just out of curiosity, so one of the things I like to do is I like to think about math. And if you are ever in a presentation with me, I always like to put things in presentations that make you think. What do you notice about this clock? Yeah, some of the numbers are missing. Where's 11 and 12? Yeah, I agree. Where are they? And the big thing I'm kind of trying to point out here is that math takes time, and you're not going to get it in a day. You're not going to get it in a year. It's a lifelong experience. Remember when I told my story about how I went through, and at first math was smooth sailing, and then it became kind of rocky for me. But then I came back to this idea of problem, that it continuous on and on and on. So this clock, you'll never get to 11 o'clock or 12, right? It's this idea that we're going to continue on and on and on. It's definitely incomplete. All right. So thinking about math taking to, and some of the things that we can do to help with this, for kids to really understand math through questioning, is that it is all about the questions that we ask to drive understanding, and that they're not going to get it in one sitting. It takes years and years of time to do this. So let's do another problem. Take a look here. It says, oh no, there are only 3 brownies, but there are 9 friends. All right, solve the problem. Someone said, cut each 3, share. What's wrong with this problem? Yeah, it doesn't ask what I want you to do, right? It assumes that you know what you're being asked. It doesn't say how many people want brownies. 6 don't get, yes, I agree. It looked like 6 would not get brownies, right? So I now added the question. Sometimes I put situations out for children to think about without the question, and I ask them to come up with a question, because that really helps us kind of think about what it is we're trying to solve. And I know for a lot of kids, they struggle with word problems. Yes, this is a word problem, but they struggle with word problems because there's so many words and they're not exactly sure what they're supposed to do with the numbers. So leaving out the question and asking them what the question is really helps. So here's the question. How will the friends share the brownies equally? What will it look like? And some people have already we're already typing this up. So if you have a piece of paper next to you, or if you just want to do it in your brain, that's fine also. What would that look like? If I wanted you to sketch it out, what would that look like? Might be something like this. Oh, look, someone did a fantastic. Look at that. Yeah, it's definitely division. Yeah, if we were doing a fair share, right? And that's something kids know all about, fair share. And you can ask them anytime, like if they're going to have brownies or cake or something that they really want, and you cut it, and it's not a fair share. As a parent, we hear about it. I know we hear about it, right? But we think about fair shares here. This actually has to do with fractions. Yeah, because fractions and whole numbers, they're all related. And this problem is really a kindergarten problem, believe it or not. But you could do it in first grade, you can do it in second grade, you can do it in sixth grade because they come up with different ways to think about it. One thing I do really want you to help your children think about is that they want to be able to draw pictures of their mathematics, not just write numbers, because pictures are extremely important as they develop their understanding, right? So you always want to draw a picture of what that looks like until they don't need to draw a picture anymore. Because our brains think in pictures. If I say the word red ball bouncing, what did you picture in your mind? You probably pictured a red ball that was bouncing up and down, right? You didn't picture REDBALL bouncing, right? You didn't picture the words, you pictured the actual image itself, right? So images play a big, important piece. In school, we call these math tasks or word problems. And they're a big part of really helping understanding as we kind of move forward. So let's talk about where you might be able to get some of these resources at. Once again, that Virginia Department of Education is a key place to find some of these resources to support you with this idea of here's some problems that I can ask my kids to help think about it. But you don't have to go to the web to ask. You could just do it in your kitchen, right? You for lunch today. When kids are going to cut their sandwich, if they're going to have a sandwich, you say, okay, I want to cut this sandwich, but I want to be able to share it with 2 people or 3 people. What would it look like and how would I cut it? Right? Back to those questions. What would it look like? How would I cut it? Some great problem-solving tasks are the ucube.org, which is a professor from Stanford. Matter of fact, that site is just a phenomenal site altogether. And then the other one is Graham Fletcher. He is a mathematician up in, I do believe, New York. And his material is phenomenal. He has ways to figure out mathematics that is really can support you as you kind of go on with your journey of being able to support your kids. So both those sites are not only good for these ideas of problem-solving tasks, but they are good just for all things mathematics. Those are 2 great sites to really kind of think about as you kind of move forward. So, after we're done today, I'm sure you'll get on and you'll explore those sites. To be honest, I've spent hours and hours on both of them. I think they're wonderful, and I think you'll find them very helpful also. So really, we did 3 things today, right? We really focused on this idea of mathematics. We need to focus on the understanding and not the answer. And we also focused on this idea of how do we focus on the understanding? By asking questions, right? We're asking, how do you know? We're asking, what do you wonder? What do you notice? And the third thing that we really talked about is that math takes time, right? And that they're not going to get it right off the bat. It takes time to develop those connections for kids. It takes time for kids to be able to develop relationships with numbers. And it will happen. I promise you, it will happen. So those are the real three pieces that you can support your child in math. Focus on understanding, asking questions, and math takes time. Now, before we get to the questions part, there's really a couple more slides I want to share with you. This is supposed to be a mirror. I wasn't sure how to do a mirror in a slide deck. But notice it talks about a math person. I'm a math person. Are you a math person? I've been very blessed that I love math, and I know that you love math too. That's why you're here. But I want to let you know there's no such thing as a math gene. Math is for everyone. Just like we say reading is for everyone, math is for everyone. There's no math gene. And if there is, we all have math genes. And then this slide. If you love math, your child will love math. And that's what it really comes down to. And if you don't love math, because some people, I'm going to be honest, still don't love math, I don't understand it, you have to fake it until you, right? So make sure that you love math and that you're excited about math, because when you're excited about things, your children will be excited about it too. So I want to say thank you, and this is the time that we're going to open it up for questions. So feel free. I think we're going to switch face actually, and I'd be happy to answer any questions.
Okay.
My son's room, he's away at college, and now this is now my office.
Ah, just get it back at all.
When he comes home, I have to go to the dining room. So.
Okay. All right. So just wondering if you all have any questions for Spencer. Some wonderful comments. Parents are saying it helped me figure out the focus of my child's math adventure, which I think is a great statement. I think, Spencer, you gave some amazing resources and great ideas to how families can talk about math at home, because sometimes I think parents don't necessarily maybe have, like, how do I talk about math, and how do we get the conversation started without my child maybe feeling overwhelmed? And I think you brought those great resources today, so thank you.
Now, this is a lot of fun. I appreciate all the families and everyone that's on this call. Anytime we get to talk about math, I'm so excited.
That's awesome. So we actually have a question. So what are some phrases to use to keep encouraging your child when she may be reluctant to engage in math or with math?
Yes. So when a child is reluctant to engage in math, I try to make sure that whatever math question I'm asking is very open-ended. So for example, when we talked about the donuts, I think everyone on the phone call has access to that, right? And why I did want to talk about, like, maybe the numbers or the different types of donuts, or how many more donuts, strawberry donuts, did we need to be the same as chocolate donuts? We could have talked about a lot of different things, but by having a picture and also leaving the question very open for a child, it allows them to access it, because everyone accesses math in a different way. And we access it from the connections that we make.
Awesome, thank you. So I know we had a family ask about, is this going to be offered for third grade? And we said, of course, we're doing a webinar next Friday for grades 3 through 6. So if you haven't registered, please join us next Friday. So another question, do you have any suggestions as to what my child should already know as they enter kindergarten? Tips on how to get my child ready to learn.
Yeah, I think especially for what I like to call the pre-K age is I would still use the same language. What do you notice? What do you wonder when it comes to things? And just start with counting, right? Counting everything. I think that's the biggest thing. And it's actually, our brain is wired that way from when we were a little kid. We just didn't realize that we were doing adding and subtracting. When you have, if you have two parents come in, the baby looks at one goes away, one comes back. So we're adding and subtracting. That's just the way our brain is. But counting everything that you can, and just talking about what do you notice and what do you wonder, because there's math in everything we do. And I love the question, what math is this? Because a lot of times kids think math are just numbers, but math is more than numbers. So I think if you kind of start that pre-K discussion around counting, and just doing a lot of counting really helps out.
Thank you. Jennifer is asking, she said she notices that her daughter often is just adding in her head. Is there a better way to encourage showing work? And she's currently a second grader.
So that is a difficult question, but I'm going to answer it this way, is that if your child is adding in their head and they are pretty accurate, that's fine. Matter of fact, when I grew up, we weren't even allowed to use fingers. Like, we were told not to use fingers. And there's actually research that shows that kids who use their fingers actually are more successful in mathematics than kids that don't. So that's kind of changed and as we move forward. Now, if kids are adding in their heads and they're not as accurate with their solutions, we need to help them think about, well, then how can we record our thinking? And not record all our thinking. Let's record the thinking that we need to write down to support us being efficient in our learning. So that is definitely something I would do. And and it changes from child to child a little bit about how much do you allow them to kind of think about, I'm just putting all these numbers in my head. If they're able to manage that, that's fine. But also if it's unmanageable, then we need to give them strategies about, all right, what do we need to write down? Do we need to write down everything? What should we be writing down? And how should we keep track of this to help our brain, as I like to tell all the time.
Oh, that's great. So another one has a question about an ST Math app for kids. How many minutes should a second grader work on it?
So that varies from school to school. So ST Math, all students in Fairfax County from K-8 actually has access to it. And so at second grade, we're talking, somewhere between 15 to 30 minutes a day, depending on what the teacher assigns. And it's somewhat challenging because there is no language in it. It's all building understanding through pictures and those pieces. It's actually a wonderful tool. I think it's harder for us as adults to kind of grapple with it, but kids seem to do much better than we do as adults, because we didn't learn that way, and they are learning that way now. So.
Okay. So Jennifer, I think, has a little bit of a follow-up with regard to her second grader. So I think she's saying that her second grader is just very resistant to showing different ways. How might we encourage some different thinking?
So one of the things I'm wondering about when it comes to Jennifer's daughter is that this idea of how often do you show your thinking, right? And is that thinking valued? And I also wonder, like, what questions are we asking that require us to show our thinking? Because, for a second grader, if the question is, 2 plus 3, they might not need to show their thinking for that, right? But if the question is like 45 plus 27, they might have to show their their thinking around that. And it really depends on the questions that we're asking the child. How much do they need to show? But I would also suggest for Jennifer to kind of model, this is the way I show my thinking, and then ask her daughter to kind of play like the teacher to say, so what do you think I can do to maybe do this faster or more efficient?
All right,
So
no, that's great.
Might help her.
So mom is saying that her second grader is using his fingers for addition and subtraction. Mom is trying to maybe teach him to do this mentally. You know, what's your thinking around kind of that, teaching that second grader around addition and subtraction?
Right. So there's a way to kind of learn addition and subtraction. The first way we learn it is through concrete materials. And concrete materials for your child is their fingers. A lot of times kids use fingers to help them, and that's why we have them. That's really allows us. But we also know that's not very efficient, right? So as to move forward, instead of going straight to like mental math, I ask kids to actually write down a picture. So if we're doing fingers, right, which is great, or blocks or whatever, the next thing we need to do is let's draw a picture of what that might look like, because the picture helps develop the mental piece of it. Because if I ask you to show me 12, most likely people are going to say 12 what? Because numerals, as we write the number 12, 1, 2, those are really adjectives, and they describe what it is. So having kids being able to draw a picture of the problem really supports them as they move towards this idea of mental math. So it's concrete, pictorial, and then it's the idea of mental math, or writing math with symbols, which are numbers.
All right. Thank you, Spencer. I think those are all the questions we have. So I certainly want to thank you so much today. This is such invaluable information for our families, and we really appreciate your time. And just to let the audience know, we have recorded the session today, so that will be available next week. And we just thank everyone for attending today, and we look forward to having you back with us next Friday and supporting our grade 3 through 6 students. So thanks, everybody. Have a wonderful weekend.